Hey guys, thanks for tuning into CMTEQ channel. So you are looking at a PWM signal with a frequency of approximately 1 kilohertz, as we can see here. Now I've got my time division here set up to 250 microsecond per division. So now you can see that I've got 1, 2, 3, 4 division for one period. Okay, now with a 1 kilohertz frequency, the period is going to be 1 over 1000, and that is 1 millisecond. Okay, so which means for 250 microsecond we're going to have 4 divisions to cover one period. That is 1, 2, 3, 4, as we can see. Right, where is this PWM signal? Well, that is the purpose of this quick peek tutorial here. The signal is coming out of an STM32 microcontroller, basically a Nucleo 64 board. So in the next couple of minutes, we're going to see how to quickly generate that signal. Obviously, you can play around with that signal. That is just a 1 kilohertz. You can play around it to generate a signal of up to whatever capability your microcontroller have. Okay, so without any further ado, let's see how we're going to do that. Right, so to generate our PWM signal, as we've seen there, you need to have STM32 Cube IDE installed. If you don't, please check the video on the description box where I got through the installation process. Okay, so now we're just going to say new here. Okay, new STM32 project. Now, if you've been using this IDE already, you might already have some project, right? But the problem is you cannot use those projects to do the configuration we're going to do, because that will require you to generate codes, and if you generate code on an already existing project, it will override all your code, right? So this is why if you want to use an existing project, it either you must use you must program it manually, okay, or you can use a template project to generate your code and then copy into your working project. Okay, having said that, we're going to select the board here, which is a Nucleo 64, and the name of my board is 334R8. Okay, then I select, it's only one here, and look at it, that's a current price. It's $10.3. They're actually selling this board currently. If you want some resource, you can download them here. Notably, that will be your usual manual. I mean, the reference manual was one of them also. And you may also download your data sheet that will give you further insight of your STM32 IC. Now, if you're done, you can then go ahead next, okay? Then we come to this important part here. This is where you will have a default location because it's not the first time I'm running it. So let's just name this program PWM, okay? PWM, we keep everything as is. You can click next. Basically here it will tell you which type of library you want to use, so you can also leave it as is, and you say finish. So now it tells you to initialize all peripheral with the default value, and you say yes. And if you didn't have the library, it will download the library because I already have the library. So the next thing is just to move into that IOC interface. So this process is going to take a couple of minutes because it needs to basically generate everything, and once everything is done, then you basically going to get your IDE ready for you to configure. Okay, and you've got a template already here that is created with all your include and your source files, okay, and then you've got your library, your sims library, and your HAL drivers library. Okay, but we are here now. So what I'm going to do here is, right now all of these are going to be generating a lot of stuff here, which basically we don't need all of that for what we just want to do here. So I'm going to go ahead and just reset this. Actually, I'm going to reset it because we're going to use an internal frequency, the internal clock frequency, not the external one. So we don't need this RCC OS out. So those are basically designed for the external oscillator here. Okay, right. So first up, you must have your STM32 Cube IDE running. If you do not have it, then you have to look at the video in the description box on how to install it with all the libraries and have your first project running. So now, because we already have it, some of us, we're just going to go ahead, STM32 project. Okay, now if you had an existing project, you could also import it. But now remember, if you import an existing project, what's going to happen is when you try to generate codes with your IOC, it's going to override your old codes. Okay, so that's not ideal. So you should either have an existing template project which you use only to generate code, and only take that code that you generate, manually type it into your main project. Now if you have it running, you can go into your board and select your board. Mine is Nucleo 334R8. Okay, so I'm going to select the board, and then I can see some of the resources about the board here. Now the board is actually being sold. This development board here is being sold at $10.32. Now you can get some of the documentation and data sheet if you want. Now I've already got all of this, so I'm going to just click next. Then we come here again. You will have a default location if you've already have this thing running. So I'm just going to name my project PWM, and then I will say finish. Okay, it says initialize all peripheral with the default mode. Now these default mode are basically related to this particular board. Okay, it's got buttons, and it will actually initialize everything with regard to this board. Then you can just run some simple code to get this board actually functionality wise running. Right, so it is done. So now you can see we've got our integrated circuit here. Now this microcontroller basically is a representation of this. But now, just to avoid this IOC generating plenty of code, I'm going to reset or clear everything. So I clear all pins out. The pin out configuration will be cleared. Would you like to continue anyway? I'll say yes. Okay, so we reset everything, cleared. Right now there is no other skeleton code that will be generated except the one that we choose. Now if you look at your main board, if you look at this particular module here, if you look at it here, you're going to see right on this side here, okay, you're going to see the PWM pins. So that is on DA11, D10, D9, D6, 5 and 3. Now if you go into your datasheet or reference manual, you realize that DA11 in particular is on PA7. Okay, so I'm going to select that PA7, then I'm going to use timer 3, because now on PA7 I've got timer 3, 1 and 17 that's available there, but I'm going to take timer 3. Okay, now we've got a channel 2 as well on it. Now notice I've enabled it, but now the state is orange, it's not green because there are settings that are missing. So I'm going to come to the timers here. I'm going to choose that timer 3, this one here. Click on timer 3. Okay, then I'm going to enable what? The clock source to be what? Internal clock source, because now remember, we're not going to make use of the external oscillator. Right, now we look at the channel. I'm going to choose what? Channel 2. Okay, so I come here, select PWM generation on channel 2. All of a sudden it's now green, so it's now happy. Okay, so now we're moving on to the next configuration to get our PWM running. Now the next settings here is the press color. So press color is literally it will tell you how many times you want to wait, okay, before you can increment your counter. Now the press color run a full STM32 clock. Okay, so the STM32 clock is running on 64 here. So what we're going to do, if we leave it at 0, it's basically 0 plus 1, but the 1 is not visible here to us because it's a formula. Okay, so if we leave it at 0, that basically means we're going to run a full clock before we increment a counter one time. So if we change this value to 3, So that basically will mean 3 plus 1, 4. So we're going to wait 4 clock cycles before we get 1 incrementation. Okay. Now, the PWM frequency, remember in the beginning we talked about the 1 kilohertz frequency. Now, if you want to get a 1 kilohertz frequency, you basically need to use the formula here. That is to divide your clock source here, right? The system clock. So you must divide that system clock by the multiplication of your prescaler value times your counter period. So that will be 64 million divided by the prescaler value times the counter period value. Now you can play around these numbers here to get your frequency, your desired frequency. So now for me to get a 1 kilohertz frequency, I gave a prescaler value of 250, right? And the counter period, it must count up to 255. Okay, and that give me 1 kilohertz. Now we move on. Auto reload. When it counts to up to 255, it's going to count up, not down. Okay, when it count up to 255, what should it do? It must start over. Okay, so we enable that. Then triggers, we don't need these settings, we can just leave it out. Then clear input, okay, we leave it like that. Then PWM generation, we chose channel 2. That's the channel that was chosen. PWM mode, there is a couple of modes here, but let's stick to mode 1. Okay, now pulse. Now this is your PWM pulse width modulation, or the duty cycle. Okay, so this percentage depend on the percentage based on these 255, like your period, where your pulses are going. So if you want 50% duty cycle here, that means you need 50% of 255. Okay, so what is 255? What is 50% of 255? You just write a number. So if we divide 255 by 2, we're going to get 127.5. Okay, but let's leave an integer here instead of a float. Okay, so we put 127. That will ensure us of a PWM of 50%. Now we're done, and we can just go ahead and generate. Okay, so I'm going to save, and it's going to generate me my code here. Let's go ahead. Okay, we are already into the main function. Right, the code is done updating. We're already in the main.c here. Now we can see our function prototypes. Now the function prototype, they relate to this configuration. So inside the main function here, we've got the HAL initialization of the HAL library, system clock configuration based on what we just did, and the GPIO init that must initialize our GPIO, because now remember we are using PA7, which is part of GPIO. So if I click on it, let's go ahead and see GPIO initialization. So we can see we only have GPIO A clock that is enabled, nothing else. That's the only thing that we've got on the GPIO initialization, because that's all we need, GPIO A clock, because we're going to get a PWM out of that port. If you comment out that code, okay, if you comment out this code here, you're not gonna get a PWM. Forget about it. Right, now the next thing is our timer initialization. So if you come into the timer initialization, you'll see our 250 and 255, okay, and the 127. So all the settings that we did are all here. Okay, so now before we can actually write this code into our program, we have to start the PWM. So that is with the one line of code for the HAL library. So that's HAL underscore PWM. Let's look at the option that we have here and start. Okay, so that's, let's take the first option here, and we're going to use timer 3, and then we need channel 2. Okay, so here it's going to be timer underscore channel underscore 2. Okay, So now I can go ahead and build this code. Okay, if everything is fine, this code should build without any problem. So let's go ahead and build the code. There we go. So the code build is done, complete without any problem. Now let's go ahead and write this code into our Nucleo board. So we're going to launch a debugger. Okay, everything is as default and we press OK. Now we wait for the debugger to launch. Now I've got the old PWM. There we go. So the code is already being loaded in and we should have our frequency back. Okay, our PWM frequency is back. Now, as you can see, it is still running at almost 1 kilohertz approximately. So now if I come down here, okay, if I change the duty cycle, right now, this is a 50% duty cycle. As we can see, if we change the duty cycle to make it maybe what 60%, let's say 60% duty cycle. I don't know what we should put here to get a 60% duty cycle, but let's say we put a value of 180. Okay, and then we load it in. So that's going to change our duty cycle. Okay, we're going to now get a new duty cycle. Right now we can see that the duty cycle have changed. We can see this is almost a 75% duty cycle because we can see it's 1, 2, almost 3 blocks. Okay, almost 3 blocks. That would have been 75% duty cycle. So that is it. The frequency is still 1 kilohertz. Now remember, if we want to change the frequency, we have to change the pre-scalar value or the time period. So now I'm going to change the pre-scalar value to 25. Okay, so if I put it 25, okay, now you can see 250. Now we went down to 25, so that is times 10. So that basically means the frequency here will be increased by times 10. So we should expect a frequency of 10 kilohertz. So let's go ahead and load this and see if we're going to get a 10 kilohertz frequency. But remember, the PWM duty cycle is going to remain the same. We're only going to increase the frequency. So let's observe and see if our frequency is going to increase here. Okay, there we go. There we go. Now we can see the frequency have increased. So what are we getting? That's 9.6 kilohertz. So that basically 10 kilohertz. So if I change my time period here, let's see here. Okay, so now after changing the time period, we can see that the duty cycle is indeed the same, almost 75%. If you want to make it 50% again, you know which value to play with. So that is it, guys, for this tutorial. So if you've learned anything, please subscribe to CMTEQ channel and give this quick tutorial a thumbs up. Until next time, cheers.